So hello everyone again. This is lecture 3 part 2 of dual nature of radiation and matter. Let's start with our further discussions which we already studied in the previous lecture. So I am Sameer Lavankar. Let's begin our discussion. So right now we are on the sixth part, that is Einstein's Photoelectric Equation, that is energy quantum of radiation. In the previous lectures we have already completed with the introduction part, electron emission, photoelectric effect, experimental study of photoelectric effect and wave theory of light. Okay, so let's start with our sixth point, basically which started in the a little bit about this. The equation part was already covered in the previous part of this lecture only. Let's start with the further discussions on this topic. So Einstein Photoelectric Equation, energy quantum of radiation. Okay, so in the previous lecture we understood the kmax value, that is equal to h nu minus phi naught. Let's move on with the further discussions. Okay, so according to above equation, Kmax depends linearly on nu and is independent of intensity of radiation as in agreement with the observation. Okay, so agreement in observation is basically that thing which was experimental study of photoelectric effect. Okay, so basically Kmax, as you already know, is equal to h nu minus phi naught. Okay, so as value as h is a constant value only, so as you can see Kmax directly depends, or it is directly proportional to frequency of the light. Okay, so it is independent of intensity because there is no term of intensity being explained here, and hence this thing again is being related to or being accurate enough as the experimental study is being considered. Okay, so this thing has been done. Next is, this has happened because in Einstein's picture, photoelectric effect arises from the absorption of a single quantum of radiation by a single electron. So why it has happened? This has happened because in Einstein's picture, photoelectric effect arises from the absorption of a single quantum of radiation by a single electron and not the continuous absorption. So because continuous absorption is not happening, this thing can be conceptualized in this way. Okay. The intensity of radiation, that is proportional to the number of energy quanta per unit area per unit time. So you can just understand this as, let me write it as here. So intensity is directly proportional to number of energy quanta. So basically if I write it as n value only per unit area per unit time. So basically this is the basic crux. What is being tried to explain here is irrelevant to this basic process. So there is no use of all these things in the photoelectric equation. Since Kmax must be non-negative, quite evident, because then only positive, as we may have heard in kinematics also that kinetic energy is equal to half m v square, as mass cannot be negative, v square cannot be negative, hence kinetic energy majorly cannot be negative. Majorly not, it is not negative in any sense. Okay. So since Kmax must be non-negative, equation given above implies that photoelectric emission is possible only if h nu is greater than phi naught. Quite evident, very simple terms, because we just need to make it as positive. So when you try to change it, it becomes h nu is greater than phi naught. Fine. So that thing is only been explained here, or we can just write it as so basically what they are trying to do, they wrote it as this is equal to this by this, which they wrote as this is equal to nu naught. So basically there is a value of frequency which should be present such that the photoelectric emission should occur. This frequency is nothing but called as a threshold frequency. So now the mathematical conceptual is also being done, and this thing is being accurate enough as the experimental study was being conducted. Here see, wave theory was not being available or not being able to understand this complete concept, but the discrete particle was useful to understand this complete concept. Okay, so same thing only. So h nu is greater than phi naught and nu is greater than nu naught, where nu naught is equal to phi naught by h. What is phi naught here? Phi naught is basically work potential. What is your h value here? That is Planck's constant. Okay. Okay, so next thing is, the above equation shows that greater the work function phi naught, the higher the minimum or threshold frequency nu naught needed to emit photoelectrons. Same thing only, so nothing much different. They are just trying to theorize everything which was being explained in the experimental study only. So show that greater the work function. So as you can see, greater the work function, the higher the minimum or threshold frequency nu naught needed to emit photoelectrons. Quite evident, as this value will increase, then this value, which is relatively depends upon the amount of electron, the frequency which you are trying to emit on the metal surface, should be much higher than this value, so that the photoelectric effect can be visible or can be observed. Okay, so thus there exists a threshold frequency nu naught which is equal to phi naught by h for the metal surface, below which no photoelectric emission is possible, no matter how intense the incident radiation may be or how long it falls on the surface. Again theoretical point only. So they are just saying that threshold frequency below which no photoelectric emission is possible is no matter how intense the radiation may be or how long it falls on the surface. That means they are just trying to make you understand again that as this value is basically depending upon, or this K max is only depending upon the frequency of radiation, such that that frequency of radiation should be greater than the threshold frequency, but as this complete term does not have any intensity in its picture, therefore it can be said that this frequency does not depend upon your intensity. That's all. They are just trying to prove all the things which were being explained in the experimental study. Okay. In this picture, intensity of radiation as noted above is proportional to the number of energy quanta per unit area per unit time. So, that thing is only explained again here. Okay. Let us move on. The greater the number of energy quanta available, the greater is the number of electrons absorbed in the absorbing the energy quanta, and greater therefore is the number of electrons coming out of the metal. This explains why for nu greater than nu naught photoelectric current is proportional to intensity. Now, just try to understand this concept here. Okay. So, please I will go very slowly. So, what they are trying to say, the greater the number of energy quanta available, let us say I write that energy quanta is as equal to n. Fine. So, as this value increases, let us say this value increases, then what will happen? Just 1 minute. Okay. So, as this value increases, the greater is the number of electrons absorbing the energy quanta. That means, let us suppose this is the metal surface. Fine. Let us suppose this is the metal surface, and in which these are the electrons being kept here. Fine. Okay. So, if this value of quanta was less, then let us say this electron were only been absorbing this energy which is greater than work function and then moved out. Now, what is happening is, because let us say I am increasing this value of n, then let us say these remaining, some sort of these remaining electrons also get absorbed or absorbed this h nu amount of energy, and those also moved out. So, now majorly what is happening in a complete sequence, what is happening is the number of electrons which are being ejected out of the metal surface have increased. So, if those number of electrons ejected out has increased, that means the amount of charge which is being passed from, let us say, point A to point B has increased. That means, if I write as small q by t, in the same time t, this q has increased. If this q has increased, that means that the current has increased. Simple concept. So, basically what is happening, if the intensity is increasing, then that means the number of energy quanta is increasing. If this energy quanta is increasing, then the number of electrons ejected out or emitted out of the metal surface has increased, and because these have increased, the quantum the charge has increased, which is being passed from point A to point B in the same time t, and due to which the current is increasing. Okay. Everything which I just spoke is being written here in these 3 lines. Okay. So, let me just iterate this again. So, greater the number of energy quanta available, this thing, the greater is the number of electrons absorbing the energy quanta, and therefore is the number of electrons coming out of the metal. Therefore, as the energy absorbing electrons have increased, therefore the amount of energy, this electron emission particle has also increased. This explains why for nu greater than nu naught photoelectric current is proportional to intensity. Okay. So, again another experimental study explanation is also been injected in this mathematical input or in this complete idea of photoelectric equation by Einstein. Fine. Let us move on with the further studies now. Okay. So, in Einstein's picture, the basic elementary process involved in photoelectric effect is the absorption of a light quantum by an electron. Okay. So, this was the basic crux which was also been explained in this where it was explained here which was explained here also. Okay. So, in Einstein's picture, the basic elementary process involved in photoelectric effect is the absorption of a light quantum by an electron. This process is instantaneous. Okay. So, as in, let us say these are the electrons, the h nu amount of particle came and got intacted, the energy got absorbed instantaneously. Okay. Thus, whatever may be the intensity, that is the number of quanta of radiation per unit area per unit time, that is, let me write it as, if I write it as n upon, let us say, A into T. The photoelectric emission is instantaneous. Low intensity does not mean delay in the emission, since the basic elementary process is the same. So, as the basic element, just what will happen is, let us say if the intensity is less, then this quanta will be, let us say, only 4. If the intensity is high, then this quanta will be, let us say, 10 or let us say 8, how much I made it here. Okay. So, this is only the explanation, but basic crux is that whenever that quanta of energy will try to touch, or let us say it goes and being in contact with the metal surface or the electron, then the energy absorbed will be very instantaneous. Only that thing has been explained here. Okay. So, this thing has also been explained. Next is intensity only determines how many electrons can participate in the elementary process, absorption of a light quantum by a single electron and therefore the photoelectric current. Okay. So, intensity only determines how many electrons can participate in the elementary process and therefore the photoelectric current. So, basically intensity depends upon the photoelectric current, only that thing has been explained here. Now, using equation given below, the photoelectric equation can be written as. So, what we are trying to do now here, so we are just taking this Kmax value, we are just changing this Kmax value to EV naught value. Okay. So, this EV naught is equal to h nu minus phi naught, which was given already for nu greater than nu naught, or V naught is equal to h by E into nu minus phi naught by E. How does this thing come? Let me try to explain. Basic mathematics only, nothing you may have calculate also in your mind only. So, it is EV naught is equal to h nu minus phi naught, right. So, this is only and only applicable when nu is greater than nu naught. Why? Because if we use this equation for nu less than nu naught, then the value of Kmax will be negative, which is not applicable, which is not possible. Okay. So, just dividing it by E value, we will get this is equal to this upon h nu by E minus phi naught by E. Okay. And that equation has already been written here. Okay. So, this is an important result. It predicts that the V naught versus nu curve is a straight line. So, if you make a curve between this value, so it is basically y is equal to m x plus c. So, here c value is basically negative abstract and m value is basically h by E, and it can be seen as a straight line here. Okay. So, this is an important result. It predicts that the V naught versus nu curve is a straight line, the slope of h by E, as I just right now told. If I just compare it with y is equal to m x plus c, where y is basically V naught and x is basically nu, then the value of m is equal to nothing but h upon E, and the value of c is nothing but equal to minus phi naught by E. Okay. Independent of the nature of the material. So, it does not depend upon the nature of the material, it only depends upon. So, there is no value or there is no relation of phi naught here, and it can be said that the slope is always constant, which is equal to h upon E. Okay. Now, so everything which is been explained here, the value of frequency, the value of relation here which is happening. So, this slope is basically been talked about, that is equal to h upon E. That is why even for those metal surfaces, different metal surfaces, the value of slope is always constant. Okay, and but only what changes, this threshold frequency changes. Because why it changes? Because the value of that depends upon the value of nu naught, which is equal to basically phi naught by I guess phi naught by h. It depends on phi naught upon h. Fine. So, as the value of V naught is a function of work potential and work potential is a function of nature of the material, that is why the value is varying for different metals. Okay. So, everything which was been explained in the experimental study is been explained here in the Einstein's equations ideas. Okay, let us move on now. So, during 1906 to 1916, so just look out the timeline also, because it is very good if we can understand that also. So, in 1905 he put this complete idea. Now, in 1906, so after that during 1906 to 1916, Millikan performed a series of experiments on photoelectric effect aimed at disproving Einstein's photoelectric equations. He was trying to disprove them. So, let us study if anything is written here. So, he measured the slope of the straight line obtained for sodium similar to that shown in the given figure. Using the known value of E, he determined the value of Planck's constant h. Fine. When he tried to determine the value of Planck's constant h, this value was close to the value of Planck's constant. So, he got the value correctly, which is approximately equal to 6.626 into 10 to the power minus 34 joule second, determined in an entirely different context. In this way, in 1916, Millikan proved the validity of Einstein's photoelectric equation instead of disproving it. So, basically it is a just humorous part that the scientist, the well-known scientist Millikan tried to disprove Einstein's photoelectric equation, but Einstein's photoelectric idea was so strong, or as we can say that he was such a prominent or great scientist that you cannot disprove his idea, and he invalidly, or let us say inhesitantly, proved the validity of Einstein's photoelectric equation. Okay. So, in this way, in 1916 Millikan proved the validity of Einstein's photoelectric equation instead of disproving it. So, as you can see, it took 10 years, he took 10 long years to just try to disprove photoelectric equation, and he tried to prove it only. Okay, let us move on. So, the successful explanation of photoelectric effect using the hypothesis of light quanta and experimental determination of values of h and phi naught in agreement with the values obtained from other experiments led to the acceptance of Einstein's picture of photoelectric effect. So, this line just tried to say that what was the basic thing which he tried to go away or different from the other people. Other people try to understand this energy absorption as continuous energy absorption, but what he said, what Albert Einstein said, that this is not continuous absorption, the small quanta of energy are being radiated and these are being absorbed by different electrons. Okay. Nothing else is being written here. So, basically this hypothesis of light quanta and experimental determination of values of h and phi in agreement with values obtained from other experiments led to the acceptance of Einstein's picture of photoelectric effect. Okay. Millikan verified photoelectric equation with great precision for several alkali metals over a wide range of radiation frequencies. So, basically finally till what is the conclusion of this complete thing is that photoelectric equation of Einstein is very correct and can be used directly. Okay. Let us move on to now photon. So, basically a little bit a crux idea of photon was being used in the previous analysis. Let us try to understand basically what is the particle nature, what is this actually photon, what is the particle nature of photon, are there any formulas related to it, etc. will be understood in this complete study of particle nature of light. Okay. So, let us start with this particle nature of light, that is the photon. So, let me go very slowly because a little bit about experimental analysis, different scientists have been explained here, and then we can go on to the main crux idea. Okay. So, the photoelectric effect thus gave evidence to the strange fact that light in interaction with matter behaved as if it was made of quanta or packets of energy, each of energy h nu. Is the light quantum of energy to be associated with a particle or not? So, basically they are just trying to say that how is photoelectric effect happening? It is happening because this energy radiation or this energy absorption is due to quanta of energy which is called as h nu, or which are having an energy which is equal to h nu. Okay. Einstein arrived at the important result that the light quantum can also be associated with a momentum which is equal to h nu by c. So, basically if you are understanding it as particle nature, because they are understanding it as crux discrete particles, that means if that particle is having some energy, then that should also have a momentum. Then when people arrived at this sequence, he only explained this idea that yes, it is having a momentum which is equal to h nu by c. What is this c? C is the speed of light. A definite value of energy as well as momentum is a strong sign that the light quantum can be associated with a particle. This particle was later named photon. Fine. So, everything just this. So, this packet of energy, this basically this discrete particle was discretized and those things were called as photon. Okay. So, this was the only idea which I need to explain here till now. The particle like behavior of light was further confirmed in 1924. Please look out to the data. So, now till Millikan, as you can see here, in 1916 he finally proved Einstein Photoelectric Equation, and after that in 1924, so after I guess 8 years, this particle like behavior of light was further confirmed by the experiment of A. H. Compton on scattering of X-rays from electrons. In 1921, Einstein was awarded the Nobel Prize in Physics for his contribution to theoretical physics and the photoelectric effect. In 1923, Millikan was also awarded the Nobel Prize in Physics for his work on the elementary charge of electricity and then on the photoelectric effect. Basically, he tried to prove it for different things. He also proved the Einstein's theory that it was correct only, and so on. We can summarize the photon picture of electromagnetic radiation as follows. So, that as I already told, this is just a little bit of scientist part only. Let us not go into that. You for your examination point of view, you should need to remember basically what is basically photon. Photon is basically a particle which we try to confirm that these are having an energy which is equal to h nu and a momentum which is equal to h nu upon c. Okay. So, let me stop it here only because the summary part will take time and it is a little different concept from the previous discussion. So, let me stop it here only. This complete summarization I will try to understand in the next part of this lecture series only. So, let me conclude it here. So, in this lecture basically what we try to understand is the complete Einstein's photoelectric equation was correct. Every observation which was present or which was being observed experimentally is being proved by Einstein's photoelectric equation. Even the intensity part, threshold frequency part, why is the value of slope constant, what is the value of that slope, all the mathematical formulations, everything was being clearly explained by photoelectric equation. Then Millikan also tried to prove it, or basically try to disprove it, but later kept on or later concluded by proving it only in 1916, and finally we understood what is basically photon. So, basically photon is a particle which is having a energy which is equal to h nu and a momentum which is equal to h nu upon c. Okay. So, this summary I will try to understand, I will try to make you explain in the next discussion of this part only. Let me stop it here now. So, thank you so much.